For this section, we're going to be talking about solving rational equations. So a rational equation is literally like any other equation you've seen before with an equal sign, but it involves a rational expression, so some sort of fraction is involved. So in order to solve this, the first thing that we need to do is we need to take every denominator of every fraction and set them all equal to 0. And then we're going to solve all of those equations that we set up. Then we're going to ignore this step and we're going to leave it toward the very end where it'll come into play. So once we solve all of those, we are then going to find the least common denominator of all of our fractions. When we do that, we will take that least common denominator and multiply it to each side of the equation or to every term, everything that's being added or subtracted. And when we do that, it's going to eliminate all of the fractions in our equation, which will then allow us to solve this problem like any other equation we've dealt with before. And finally, from there, once we've solved, we will then reject any of our solutions from step 5 that match our solutions from step 2. So note that step 2 and 1 gave us all of the values where our denominators could equal 0. So by rejecting any of those values, we're saying we cannot allow division by 0 to be one of the answers, as that's impossible. Okay, so we're going to go through a few examples here. The first example, we have x plus 6 over 2x plus x plus 24 over 5x equals 2. The first thing that we need to do here is set every denominator equal to 0 and solve. That'll give us all of the values that we need to reject if they match with our solutions at the end. So we're going to take 2x and set it equal to 0. And we're also going to take 5x and set it equal to 0 and solve for each of these. We'll divide each side by 2. Sorry, I made that fraction a little too long. And then we'll divide each side by 5, which gives us x equals 0 and x equals 0 again. So this is saying that x cannot equal 0. These solutions, or really this one solution since they match, mean the same thing. If we get an answer that is x equals 0 at the end of solving this problem, we have to say that there is no solution because it would match this value that cannot be our answer because it causes division by 0. Okay, so getting back to the problem now, we now need to find our least common denominator between 2x and 5x. So to find a least common denominator, we start with our first denominator, which is 2x, and we check if the second denominator has anything that we do not already have. So notice there is a 5 here that we're multiplying by. We do not have a 5 multiplied in our LCD so far, so we multiply by 5. Now there's an x, but we already have one x in our LCD, so we don't need to worry about it. If there were 2 x's, meaning x squared, then we would have to add one more x since we only have one of them. But we already have one, we don't need to write it down again. Only what we're missing. So that means our least common denominator, or LCD, is 2x times 5, which is 10x. Now we're going to take that 10x and multiply it to each side of the equation, or multiply it to every term, which has the same effect. So I'm going to write that out as a new step. This way things don't look too messy. We're multiplying 10x by x plus 6 over 2x. Since we're multiplying it to a fraction, we'll go ahead and put 10x over 1, as it doesn't change the problem, and it allows us to multiply a bit easier. Then we're going to say plus 10x over 1 times x plus 24 over 5x. And finally, 10x times 2. Again, if you're not comfortable with why we just multiplied 10x to each of these terms, it's the same thing as if we had written 10x multiplied to the entire left side and 10x multiplied to the right side, and then distributed the 10x. It's going to get multiplied to every term that's added or subtracted. Okay, now from here, notice why we just did this. We now have an x in the top and bottom of these fractions that's going to cancel out. And we have a factor of 2 in the top and bottom. 10 divided by 2 leaves us with just 5. And over here, we now have an x in the top and bottom that we can cancel out. And 10 divided by 5 gives us 2. So we no longer have any fractions in this problem. All the denominators were eliminated. They were only ones now. We're only left with ones now, that is to say. So we have to solve 5 times x plus 6 plus 2 times x plus 24 equals 10x times 2 is 20x. And now it's just a matter of solving a standard equation. We're going to distribute the 5 and distribute the 2, which gives us 5x plus 30 plus 2x plus 48 equals 20x. Combining our like terms together, 5x plus 2x gives us 7x. 30 plus 48 gives us plus 78. And that's equal to 20x. From here, we need to combine our like terms, so we need to move this 7x to the other side. We'll subtract 7x from each side, which gives us 78 equals 13x. And dividing each side by 13, we are left with 78 over 13. And with a little bit of division going on here, this should end up being 6. So just a quick check. You could always do long division or multiply it. 13 times 6, we multiply the 3 and 6 together, which gives us 8. Carry the 1. 1 times 6 is 6, plus 1 gives us 7. So it does check out. It's always a good idea to double check your math. So from here, we now check, does our answer match either of these values? If it does, then we have no solution. But in this case, 6 does not match 0. That means it works. It is not rejected. It is accepted. X equals 6 is the solution to this original problem. Okay. Moving on to this next problem. We'll try this one together, and then I'll have you all try the next one. This next problem is very similar, but it shows us another method that we can sometimes use with these problems. Just like before, the first thing that we want to do here is set each denominator equal to 0. So we need to set x plus 10 equal to 0 and x plus 4 equal to 0 to find any values that need to be rejected. So we'll subtract 10 from each side to get x cannot equal negative 10. We'll subtract 4 from each side to get x cannot equal negative 4. And now from here, our next step would be to find the LCD and multiply it to each side. But whenever you have one fraction equal to another fraction, meaning nothing else is being added or subtracted or multiplied or divided, anything like that, just two fractions equal to each other, then you can use cross multiplication to solve the problem. It has the same effect as multiplying by the LCD, it's just a much faster method in this particular type of case, and it comes up very often in mathematics, so it's good practice to use it whenever you can. So cross multiplying says we're going to take the top left, multiply it to the bottom right. We'll take the bottom left, multiply it to the top right, and set those values equal to each other. So x plus 1 times x plus 4 equals x plus 10 times x minus 2. This is the same thing as if we multiplied by the LCD. So now it's just a matter of solving. We're going to start distributing these. So x times x is x squared, x times 4 is plus 4x, 1 times x is plus x, 1 times 4 is plus 4, and that's equal to, again, we need to distribute the x and the 10, so we get x times x is x squared, minus 2x, plus 10x, minus 20. And now we need to start combining like terms by moving them on each side of the equation. So we have an x squared here and an x squared here. If we subtract x squared from each side, both of these are going to cancel off, which will make the problem much easier to deal with. Now, combining our like terms, we have 4x plus x is 5x plus 4 equals negative 2x plus 10x is 8x minus 20. And now we need to get our like terms together again. So we need to move one of the x's over to the other side. In general, you want to move the smaller x over. It lowers the likelihood of having to divide by a negative number. It doesn't always guarantee it, but it definitely helps. So we're going to subtract the 5x over to the other side instead of subtracting the 8x. And when we do that, we're left with 4 equals 3x minus 20. We'll then add 20 to each side of the equation to get 24 equals 3x. And finally, we'll divide by 3 to get our x alone, which gives us x equals 8. It's perfectly okay to move the x and the 8 over to the other side. Before, if we had just kept solving it the way we were, we would have gotten 8 equals x. It's the same thing. So, x equals 8 is our solution. We said to reject negative 10 and negative 4. We don't have either of those, so x equals 8 is the final answer that solves this original problem. Okay, for the last problem, I want you to take a moment, pause the video, and see if you can't work through this. All right. So for this problem, we have 1 over 2x plus 2 plus 2 over x plus 1 equals 5. The first thing we need to do is set each denominator equal to 0. So 2x plus 2 equals 0. and x plus 1 equals 0. And we are going to solve each of these equations, so we'll subtract 2 from each side to get 2x equals negative 2. Divide each side by 2 to get the x alone, which gives us x equals negative 1. And then subtract 1 from each side to get x equals negative 1 again. So remember, this tells us x cannot equal negative 1. From here, we do not have two fractions equal to each other, so we will need to use the multiplying by the LCD method. And in order to find the LCD, the denominators have to be completely factored. So we need to factor this 2x plus 2. We can factor out a 2. That's our common factor between those terms, leaving us with 1 over 2 times x plus 1 plus 2 over x plus 1 equals 5. And now we'll create our LCD that we will multiply by. So the first thing to note is we take our first denominator and start that off as our LCD, and then we check if anything is missing. So moving on to the second denominator, we have x plus 1. X plus 1 is already included in the LCD, so we already have the LCD. It is just 2 times x plus 1. That's what we're going to multiply to every term. So we take 2 times x plus 1 over 1, and multiply that to 1 over 2 times x plus 1. Again, we add 2 times x plus 1 over 1 and multiply that to 2 over x plus 1. And finally, we multiply the 5 by 2 times x plus 1. Now we start canceling terms. This should get rid of all of our fractions if we found the correct LCD. So notice the 2's are common on the top and bottom of each of these fractions that are being multiplied. So we cancel the 2's, and the x plus 1's are common. We cancel the x plus 1's, leaving us with just 1 over 1, which is just 1. Plus, here, the 2 is not common in the top and bottom. We cannot cancel it, but the x plus 1 is. So we cancel that, leaving us with 2 times 2 over 1. That's just 4. And that's equal to 5 times 2 times x plus 1. When we start multiplying that, initially we get 5 times 2 is 10 times x plus 1. And now this is just a standard equation to solve. We will distribute the 10. We will add the 1 and 4, so we get 5 equals 10x plus 10. We'll subtract 10 from each side, which gives us negative 5 equals 10x. And then we will divide each side by 10 to get the x alone, which gives us x equals negative 1/2 when we simplify. That does not match our rejected value of negative 1, so this is the answer that solves the original problem. X equals negative 1/2.